Hypermesh software. Uh, so today morning we have seen the basic of finite element method and how to solve the engineering problems by different methods, maybe numerical method, analytical method, and experimental method, right? And we have seen that that all these finite element analysis or finite element methods come under numerical methods. So you will get the approximate solution, not actual solution. And this approximate solution, you will you cannot believe directly on this approximate solution. For that, you have to take care that either you can validate that results with either numeric analytical method or maybe experimental method. So in this today's session, we are going to demonstrate whatever we have discussed today morning. Means what actually we are going to do? We are going to take an actual problem, simple, very basic problem. From the scratch, we are going to start it, and then we will solve it. But before going to solve this particular problem, what is necessary? You should know the user interface of the software and the tools, their files, and other options from the software. And that would be very easy. That not so much difficult. Just do remember one thing: the learning of software is not so much difficult, but understanding the theory and interpret that result is very important here. Because if I teach this particular software to the school level student, he can also operate. But do remember, we don't want to be a operator. We have to use this particular software as a tool only. Okay. Otherwise, everything we have to understand by some theory or principles. Getting so and the methods obviously. So you might have learned this finite element method in one of the course, finite element analysis. So the basic funda you might have cleared in the theory part. So I will not go in so much depth in the basic, but when as and when required, the basics I will just clear over there. Okay. So next part is there that I will go to the morning PPT, and here if you observe here that we have seen why do we carry out the meshing, and as usual you know that. So when there is a small problems, let us consider take a we require to find out if it is we require to find out the stress and displacement of the cantilever beam. Okay, cantilever beam. In the cantilever, one end is fixed, other end is subjected to tensile force, or maybe you can consider as a let us check this one. So one end is fixed, other end is subjected to tensile force. So such problems, if this the level of the problem is very simple, then we can calculate by hand calculation, by analytical method, and we can easily get the stress value and displacement value, right? um, you know that how we can calculate the stress. Can anyone tell for this particular problem? This let us consider this is a rod. One end is fixed, solid rod is there, having diameter is 50 mm, and the one end is fixed. Fixed means all degrees of freedom restricted, and here other end is subjected to tensile load, pulling action with a magnitude of 1 lakh Newton, and the distance from one end to other end is 500 mm. Let us consider, and you will be asked can explain it. Okay. So first of all, tell me, suppose if I want to implement here analytical method. So how we can implement it here? If I want to find out the stress value, so how can I implement the stress value? Sorry, how can find the stress value here? Is there a formula you can tell me? Yes, who will tell? Abhijit, Kumbar, Rutuja, कौन सांगते? Am I audible to you ना? Hello? Hello?
Yes, sir.
Yes, sir, you are audible.
Just give me reply. Otherwise, don't worry about the answer, but give me reply. Otherwise, I'm not getting whether I'm in the meeting or not because the connection is interrupting. So just tell me first whether am I audible to you or not. Let us forget about the answer, but tell me first whether am I audible to you or not, and then think
Yes,
about the answer.
sir.
Okay, okay. Then
Yes,
what we are
sir.
talking about that how we can find out the stress value here, stress and displacement. So can you tell me formula how we can find out the stress? Basic formula, strength of material.
Force upon area.
Right. The stress is equal to force upon area. So force is here 1 lakh Newton and area of this cross section pi r square, right? So if you put this formula 1 lakh divided by pi r square, r is a 25 here. So you will get the Newton per mm square. Stress is in Newton per mm square. This is the analytical solution, right? But we can solve this analytical solution or we can get this solution by analytical method when the problem is simple. But instead of this, if I give you chassis or if I give you roll cage and if I ask you to find out the stress value by giving whatever the given things, I will provide all the things, whatever the force and area, other things I will give. But are you able to calculate the stress, actual stress, or by analytical method? The answer is no. Why? Because the problem gets that solution will be complicated. When there is a simple problem, one part is there, so we can easily calculate the stress value. Why? Because it is very simple, force upon area. But whenever there is a complicated problem, it is very difficult to solve the question that problem with the analytical method, and hence we are using numerical method over there. Okay, so such a complicated problems can be easily solved by numerical method, but we are not getting actual value. We are not getting actual value of the answer in the numerical method. So we will go close to the actual one. Means let us consider it is a 50.95. So we can go up to the 50.85 or maybe 50.67 or something, that value you will get. So we are reaching closer to the actual one. And how we can find out the displacement? What is the formula for the displacement? Cantilever beam, here it is a rod element, rod subjected to a tensile force. So how we can find out? Yes. Am I audible, na?
Yes,
Hello. Now, yes. Who will tell how we can find out the stress? Displacement.
sir.
Finite
PL
element
by
method.
AE.
Yes, yes. Who is telling?
Abhijit.
Abhijit, tell me.
PL by AE.
P for force.
Force.
FL by AE or PL by AE. F is equal to P means force. L is the length, and AE means A for area, E for Young's modulus of that material. Suppose if it is a steel, the Young's modulus is different. If here it is Young's modulus 2.1 into e raised to 5 Newton per mm square. If it is aluminum, then again it is changed. Or if it is any other material, copper or other thing, then also it is the E value will be changed. Okay, so according to material, that E value change. So here FL by AE or PL by AE formula is required to use, and then you will get the displacement in terms of mm, 0.12 mm. So this is what the analytical method. Getting? This is a analytical method. And analytical method basically we require to do the calculation by hands by using formulas and whatever the relations are there. So according to that you will get the solution by analytical method. But in case of a numerical method, we have to use the methods like finite element method, finite volume method. So that kind of methods we have to use in case of a numerical. And suppose this same problem, if I want to solve by experimental method. So there is a UTM machine, uniform, that testing machine is there, na? Okay, so that UTM machine you might have worked or you might have experimented during your material practicals. So there is a one machine that both ends are pulled by, or one end fixed and other end is pulled by force of 1 lakh Newton with the same diameter, steel material, and the length is 500 mm. So same specimen or that bar we require to take, then we have to install it on UTM machine, and then we require to pull it by 1 lakh 1 lakh Newton force. And according to that you will get the displacement and stress value by some small calculations. Okay, or maybe if it is easily available on the machine, then you can just require to record that values, so you will get the that particular answer. So this is what the experimental method. So I have explained here all three methods for simple problems. Okay, but whenever there is a chassis, whenever there is a roll cage, whenever there is a engine block or other something complicated structures, so it's very difficult to do that by, or to get the answer by experimental method or maybe analytical method. So that numerical method comes into the picture. And that is what we are going to learn in this particular course, numerical methods. And numerical methods already you might have learned by some hand calculation or by manual method in second year. Okay, that different methods, that Newton-Raphson's methods and other things, different methods are there. Forward interpolation, backward interpolation, and then you are iterating it. First iteration, second iteration, third iteration. Even though if you take 100 iteration, then you will get the same value or result you will get. Okay, so that same principle this software is going to use, and the software is a tool. Instead of manual calculation, we are doing calculation by manually. So same problem you can solve by finite element method also. You might have learned these problems in your theory part. Okay, finite element analysis part. How to solve that? By matrix, different matrix you are supposed to use, and then different displacement matrix, then k value you need to find out, and then force, and then other things. Some costly process. Okay, so but here in analytical method there is a limitation. Of such methods. Okay, so that's why numerical method comes into picture, and that's why it is popularized. And in the numerical methods, we are there are in the market, there are different number of tools like ANSYS, Hypermesh, LS Dyna, Hyperworks, or maybe abacus. Different tools are there. Okay, by using that tools, we can easily solve the complicated problems. But limitation only is that whatever the results you will get, that will not be exact solution, that would be approximate solution, right? So we will stop this discussion here, and I will switch slowly to the software. Do remember, we are going to slowly move to the software, and we will start software from the scratch itself. Not if I go directly in the software, so basic funda or the theory or fundamentals behind the software, you will not able to understand. That's why I'm focusing on the fundamentals first, and slowly we are going to move to the next part, that is what the software. So already I have told you, the software, using of software is not a big task. If even though if I teach this particular software to the school level student, he can able to easily use that particular software or access that software, but he will not get what or he will not able to interpret the results, or maybe he will not able to interpret or correlate with the actual that simulation, or maybe that particular analysis. Okay, so is it clear? This method, three methods. And then main numerical method or finite element method is very important, that whatever the infinite solution or infinite problem, we are going to convert it into finite one. Because when you take as it is, that there would be a number of points or infinite points. So, and each point having 6 degrees of freedom. 6 degrees of freedom means we can rotate this movement of that particular point will be in a 6 direction, 6 degrees of freedom, 3 rotational, 3 translational, x, y, z, u, v, w. Okay, so there would be 6 into infinity equation, number of equations, that many equations you supposed to solve. And then here it is we are going to restrict this whole problem into finite one, infinite to finite. Okay, so the finite one, 8 elements are the 8 elements or 8 nodes are there. So 8 nodes into 6, 48 equation need to be solved. So it would be finite. Okay, so that is what the conversion. And we have seen that 1D, 2D, 3D. Again, I am going to go in detail whenever, as and when it is required, 1D, 2D, 3D. So when to use the 1D element, when to use the 3D element, when to use the 2D element, and other mass element, spring element, damper element. So according to the application, these elements are required to be used. Now, let us talk about the this particular software. So this is a user interface of particular software. So just I will quickly go through this, and then I will move to the software, so that would be better to understand. So here you can see, as usual, here it is a title bar, then here it is a menu bar, file, edit, view, collectors, then there are different tools, materials, and other things. So this one is a menu bar. Then there are toolbars are also available on the 3 side of the software here. Okay, so one here toolbar, here some handling tools are there, here some main toolbars are there, here some visualization, for visualization some tools are here, and this one is a graphics area where you have to do your modeling and other things, and that would be visible in the graphical area. Then here it is main pages. You can see 1D, 2D, 3D, the pages are there. Then here it is a command window. You might have seen that in AutoCAD we can put the command and we can use the tool also. Similarly, this software also the facility is there that you can find the command window. And then here, but we are not using command window. We are directly taking it from whatever the tools are available. And then here it is a menu bar, main menu. So you can consider here main menu. In the each page there are different menus. And here it is a history will be generated here, tab area, history will be generated. Some here opening and closing files are the tools are here. So this is what the particular the user interface of the software. Now uh, just reply me, can you see the software user interface on the screen? Hello?
Yes, sir.
Yes, sir.
So quickly reply me. So I will get. I'm getting that. So I can move ahead. So once again, I'm telling you the user interface of the software. So you can see here. So here it is a main menu bar. There are file, edit, view, collectors, the different geometry, mesh, other menus are there. Then here you can see some import export filing or files importing exporting, the symbol is there. Then here some orientations are there: xy orientation, yx orientation, zx orientation. Here isometric view you can view. So this visualization toolbar is there. Some here handling toolbar means span, zoom out, then rotate. So such tools are available here, and same can be done by your mouse and keyboard. So by using control button, by using left right click, you can handle the same. Okay. Now next part is here some you can there are tools which are used for to view the different uh, style of that particular geometry. Here is also main menu is here, different main material component, then properties are there. Then next, here you can observe geometry 1D, 2D, 3D. These are the page. So geometry, there are different tools. 1D analysis, there are different tools. 2D analysis, there are different tools. 3D, different. Analysis, constraint, load. So these are the some options are there. Then tools for scaling, translate, rotate, position, assemblies, color, then faces, features. So these are the different tools are as and when mask, delete, find. So these are the tools we are going to use for editing the your model. Okay, and then finally it is a post. So we are not going to is a hypermesh, but if you consider this hypermesh, it is come under umbrella of hyperworks. It is come under umbrella of hyperworks. So I will quickly go to the start menu, and then I will use here hyperworks. Okay, hyperworks. Okay, so in that umbrella you will get the different softwares: hyperworks, altair. So it is basically designed and developed by altair engineering. Okay, altair engineering. Okay, so that in the altair engineering there are different softwares. For meshing purpose they are using hypermesh. Okay, for result viewing they are using hyperview. They are considering hyperview software. Okay, so that you will get. And then solver also, there are different solvers are also there. So if you consider this one, if I click here, load user profile, there are different solvers. Basically finite element method problems can be solved by 3 steps. One is a pre-process, second one is the process, and third one is a post-process. In the pre-process, what we are going to do, in the pre-process there is a required to model the problem model. Okay, then we have to give the construct that we have to give the boundary conditions, and then load conditions in the that part. In the second part, process, we have to solve this problem. Okay, and that when we run the model, then you will get the that behind this software, that compiler will do the calculation and the result will be stored in the software itself. But how to view that result, that come under post process. Okay, post process. In the post process part, you have to view the result by using some tools, or maybe some tools, other tools, or maybe by some small software packages. So here it is Hyperview we are going to use to view the result. Okay, and these are the solvers. Solvers means that going to solve the problem. So default solver is Hypermesh. Here it is a Radios solver, OptiStruct solver. Radios, we can static structural dynamic problems, we can solve it by Radios, but OptiStruct is required to solve for optimization problem. OptiStruct solve can any problem, but Radios cannot solve. Okay, optimization problem we require to use the OptiStruct here. Then Abacus is there, Actron is there, ANSYS is there. So OptiStruct and Radios is the come under umbrella of Hyperworks itself. So Hypermesh, Radios, OptiStruct, Hyperview, that come under Hyperworks. Okay, main branch. Okay, and then Abacus, Actron, ANSYS, LSDyna, these are the solver developed by some other industry, but these are the compatible with this particular software. We can extract or import or export ANSYS file to here or from here to there. Some files, not all. Okay, with some dot extension. So dot IGS, dot FEM. Likewise, the files names are defined. So that also we are going to learn in the next coming practicals. Now, so these are the solvers. Do remember, we are using OptiStruct and Radios solver for this throughout the analysis solving. Now, how to start the software? When it is installed on the software here in your desktop, you can put the Hyperworks in the search menu, or maybe you can create the shortcut on the desktop and just click, then this window will be open. Okay, so this is main default window. Along with this one is also open. So when it is open, you have to select the solver. So we have to select the solver OptiStruct and say OK. Okay, this is what the first process, and then this come into picture, that this user interface, right? Now again I will go to the actual problem. Now we have to solve this problem, or we have to model this problem in the Hypermesh. So how to model it, that I'm going to explain here. But before that, it is better what we can do, we will go slowly, and during this solving the problem I will explain the basic keys, then mouse keys, then control shift button, how we can use for solving the problems or to operate the software. During that, if I tell directly the use of these buttons or shortcuts, it would be difficult to remember. But when we apply it for solving the problem, then it would be easy to remember, right? So am I audible to you, everyone? Yes, Zai, Aditya Mane. Hello.
Yes, sir.
Yes, sir.
Okay. So during the lecture, I'm going to ask anything to anyone. So everyone should, so that will clear that everyone should in the lecture with their not only with their cell phone, but with their whole what we can say, the participation would be in the lecture. So I will confirm that. Okay. Yes. Then what I will do next part is we will solve this problem. So while solving this problem, we have to first 3 steps we need to follow. One is pre-process, process, and post-process. In the pre-process, we have to model it, but there is one formula for any kind of problem. If you want to solve, there is a formula MHPCLL for Hyperworks. MHPCLL. So M stand for material collector, H stands for hyperbeam, P stand for property collector, C stand for component collector, L stand for load collector, and L step stands for load step. So you can note down this one MHPCLL because this is required to remember every time. When if you want to solve any problem in the particular hypermesh, we have to use this formula MHPCLL, or sometime we require to skip this hyperbeam. We have to use the MPC. MHPCLL every time we require to use it. Okay, now the first thing is that here after this my explanation, you have to use your software and then you have to solve this problem, same problem in your software, and then finally you have to prepare the report, and that is required to upload on the Moodle so I can access it, and I can assess that report, and I can grade you, okay, according to your report and understanding. Okay, now as usual our formula MHPCLL. So we have to find out M for material. Okay, so here the main menu MHPCLL you will get here. Some part of the MHPCLL you will get here. So you can observe here. Here it is component collector. Here it is a material collector. Here it is a property collector. Here it is a load collector. And only remaining is that hyperbeam. Hyperbeam you will get the 1-day analysis because we are doing 1-day analysis. So here you will get the hyperbeam, and load step you will get in the analysis. Here you will get the load step. Okay, so try to write the steps, or you can remember the steps. Both option you have with you. So it is better small main part you can write down in your notebook. So that can be easy for you to remember, and you can use that notebook for whenever you do the practice in the software, because there are many steps and it's very difficult to remember simultaneously. Even though if I know, or if I know everything today, and if I try to use it after 6 months or 1 year later, it's very difficult to remember. So so already I have told you this is only tool, and that tool not required to remember. When you go into that particular software, then automatically everything will be uh, remember if you know the logic, if you know the steps. So that's why I'm telling you that MHPCLL, that should be fit in your mind. And if that logic, if you know, then you can easily handle the software at as and when required. Okay, at any time. Okay, now so I will start with material. So here it is a material symbol. You can click on the material. So basically there are different collectors. Collectors means, let us consider if you want to prepare a Diwali Pharal, okay, Diwali Chivda, okay, and that what are the different components in the that constituents in the chivda. That maybe I will use Marathi words here because that very familiar with us. So there is a shengdana, then kani काय काय masala असतो, then khobra असतं, then poha असतो. So that different collectors at a time we cannot mixture it. There would be different collectors. For poha different one, for shengdana there is a different one, फॉर जे नारळाचं खोबरं असतं त्याच्यासाठी डिफरंट असतं. अँड these are the different collectors, and then we will process it properly, each and every component, and then we will connect to each other, means mix to each other. The same software logic is also similar. There are different collector: material collector, hyperbeam collector, load collector, component collector, and that are there. And when we link together all these components, and if we solve it, then you will get the result. So similar to when we mix it properly, that all components in the Diwali Faral, then you will get the very beautiful and very tasty chivda at the end result. Same here, at the end you will get the stress value and the displacement value. Okay, without doing any calculation. Okay, so here material is there, and then name of the material we have to put. I can put here steel. Steel. You can use any name. Maybe you can use your name also, like Ravi, Shankar, whatever you want. You can use your own name, but it is better, as we are engineer, that it is better to use the actual name of the material, steel, or you can define your own material also. Okay, so it is very user defined functions are there. So user have to define the functions, different functions, and then we have to choose the color. You can choose any color, but only do remember there should not be repetition of the same color. Okay, so there are different colors. So I will use this one, or maybe you can use the here likewise this one. Okay, so this one, once it is used, this should not be used again, because every component or every collector we require to give the different color. Then type of material is isotropic. There are different types of material. The properties of the material, if it is not changing with direction, okay, so then it is called as isotropic, and if it is changing, then it is called as a the anisotropic material. So what are the isotropic, like you can steel, aluminum, so these are the. Can anyone tell me anisotropic material? Anisotropic or orthotropic? Orthotropic, orthotropic material. Okay, you can put in chat room during the, or maybe at the end of this session, uh, orthotropic materials. Okay, so I will give you example. You tell me which type of material is this one. There is one wood, and then composite, and steel. Okay, so you have to tell me. I will use the chat room here, so it would be better for me. Or do you remember? You can remember wood, steel, and this one composite. Which kind of material? Orthotropic, anisotropic, isotropic. Sorry, me. Last time I have told you just anisotropic. It is orthotropic. I am talking about orthotropic. This one is the isotropic. So that's why here it is a isotropic material. Steel. So already one material, one answer is already I have told you, that is an isotropic material. And then card image, mat one, because there is a card image. Card image means what? Card image is, let us consider, this is a ready masala. Ready masala. Okay, ready masala. In Diwali Faral, some ready masalas are available. Okay, in the market. Directly we can take this one and put it into this Faral to increase the taste of that material, or it is required. Or another option is there for that we can prepare our own masala at our home. So here mat one is mat one, and when it is depends upon the temperature, then or thermal type of analysis, we can consider the mat 4, or you can use the help menu and you can find out the what is meant by mat 1 and mat 4. I will explain you this part in the next session. If I explain this here, then it's very difficult to complete the problem. Okay, so I will explain it at the next technical. So now you just remember mat 1 is a ready masala and type is isotropic. So that would be required to select here, and every without thermal problem you can use the mat 1 as a card image. Okay, and then go for, instead of create, you have to go for the create edit. So when you go for the create edit, here there are different properties. So here is a E, we have to on it, Young's modulus 2.1 e raised to 5, and the Poisson's ratio 0.3. Okay, This is a Young's modulus. This one is a Poisson's ratio. Young's modulus and Poisson's ratio. So these two we require to set here and then go to the return. So when you go to the return, then you can, in the history, you can find out the steel material is there, green color that we have used here. And so that history is created one by one history, whatever you are going to do, that you can do it here. If you want to delete it, right click, you can delete it, card edit it or delete it. Okay, if you want to edit it, otherwise we can keep as it is. Okay, now next part is that material part we have completed. This material part, material collector we have defined. Now we have to go for the hyperbeam. So hyperbeam you will not get here. Hyperbeam you will get in the 1D page. Hyperbeam. Hyperbeam means what? Cross section or that model. Okay, section. So here if you observe that section, sorry, here section is circular section and the rod is there, solid rod. So that section we have to define. So here section, standard sections, we have to go into this. There are different sections, but we have to go for the standard section because this is a standard section. Hyperbeam. If you go to this one, there is a thin walled tube, hollow tube is there. Solid rectangles are there. Solid circles are there. I section, C channel. Basically, I section, C channel for the chassis. There are used H section, T section, L section. So these are the different sections. So here it is a solid circle. We have to create that solid circle. So solid circle, the diameter is, if you observe here, diameter is 50 mm and then length is 500 mm. So here radius we require to put circular section 25 radius. Enter, then it will be radius will be 25. Section circular section 1. You can define number of sections also. Okay, once it is defined section, all the calculation for the section that will be calculated automatically here. Radius of gyration, torsion constant, wrapping constant, then shear centers, then centroidal, moment of inertia, everything will be calculated automatically. Okay, so that would be considered here. And then we have to click on the model view. If I click on the model view, that will directly store here beam section as a here. Okay, hyperbeam. Okay, then go to the return. So H part is completed. MHP, we have to go for the property now. So property here, you just go to that, go with that cursor. You will get the drop down box properties. Go to the properties. Here we have to create the property. We have to give the name of the property. We have to give the C rod. You can use capital or maybe you can use small letters, no matter. C rod. Color we have to define. You can define color, any color. Then that should not be repeated. Here it is a 1D analysis. So that's why it is required to choose 1D. Then card image. Card image, already I have told you, this is a ready masala. Ready, everything will be calculated over there. As like we have seen that for hyperbeam. Same way, we can use here P rod because we are using rod element here. P rod we have to use. Rod element, P rod. Okay, P rod. Then material we have to select. We have defined material steel. Click on that, double click and click. Okay, so this one beam section we have to define. Beam section means we have defined beam section as a circular solid section. So double click and circular section we have to define circular section. So everything will be picked up that properties and that will be assigned to that material and then go for the create edit. So when you go for the create edit, here it is different calculations will be calculated. Rod cross section is calculated here automatically, and we can see here property with a different color. Make sure that the color should not be repeated here. Now go to the return. Here it is a property is completed. Now MHPC collector component collector, MHP CLL means component collector. Component collector means we have to prepare a geometry here. We have to prepare the geometry here. So how we can prepare a geometry? We have to give here component rod component. Then we have to give the color as a component color. So I will use green but different one. Okay. Then no card image. Here it is not required card image. So whatever the properties are there, that we have to define here properties. Means we have defined property here, but we have to assign it here. So double click C rod. C rod, card image P rod, material steel, card image mat 1. Whatever the property we have defined in the material as well as this one property automatically picked up by the component. Means it is interlinked. You can see here links. Okay. So it is interlinked and then created it. Okay. Component is created here. Now you can, it is here, then immediately you can create the component. So go to the geometry. For creating component, we have to go to the geometry. So what we can do, we will create two nodes, first node and end node with a distance of 500 mm. Okay. And then one node we will going to fix and other node we are going at 0, 0, 0, x, y, z direction. Here it is a 0, 0, 0. So x 0, y 0, z 0. Create. But it is not visible here. It is created but not visible. So we have to fit the screen because the area is very large. So we have to fit it. So when it is fitted, it is displayed. Okay. Now second in x direction 500 mm because length is 500. So create and then again put it in. So there is a two nodes will be created. So nodes are created here. Then go to the return. Then we have to give the element over there. Okay. So we have to go to again 1D page, 1D, and there are different elements, 1D elements, bar, rod, rigid, rib, spring, gaps. So these are the different elements. We have to choose as a rod element. Okay, rod element. Then create element. Instead of update, we have to create the element. So first of all, we have to select the property C rod. We have to define here C rod. Element type. Instead of C weld, we have to define the P rod. P rod we have to define. If you miss it, then C weld properties will be assigned to this particular element. So always do remember element type properly need to be selected. C rod and property C rod element type P R rod. Okay. Here it is a R rod. Okay. Or you can use instead of R rod, we can use the C rod here. Okay. C rod element type C rod. Okay. It is better. C rod. What are the meanings of this C rod, A rod? So that these are the element types, rod element, and having degrees of freedom. In terms of degrees of freedom, it is defined rod element. So that you will get it how it is defined. So element C rod we need to select, and if you know the properties of the C rod, then you can use the help menu, put it C rod, everything you will get. Okay, related to this. So that exercise we will do at the next session because at least we have to complete this one problem. Still there are 10-15 minutes, so I can complete it and then we will stop the lecture. Okay, so I have to go somewhat faster. So I will go to the node, select it here, first node, select first node and then second node. So automatically that element will be created. Go to the return. Then if you want to require to represent it 3D, now you can see control button and left click, you can rotate it. Control button, left click. Control button, press on the keyboard, and mouse left click. Pick up the left click, hold it, and rotate it the mouse. So you will get it. Okay. Now this is a 1D representation. If you want to 3D representation, click it here, representation, 3D representation, and pick it here. So that rod is generated here. Okay, but for our convenient, we are going to traditional represent it. That would be better for your applying the load conditions and boundary conditions, other conditions. Okay, so that would be here. So here it is a representation. Okay, then that component is created, load collector component. Then we have to go for the load collector. Okay, we have to define one end fixed. What are the boundary conditions are here? One is fixed condition and another is applying the load at the other side. Okay, so here we have to create the load collector. Go to the load collector. Here it is a load collector. Then give the create first single point constraint, SPC, single point constraint. Here it is only single point. So we have to give the single point constraint, all degrees of freedom. Color I will keep as it is, and then no card image, create. So here it is, you can see SPC is created. Okay, and we have to define on this node. So we have to go to the analysis and go to the constraint. Constraint means all degrees of freedom restricted at this point, fixed condition. Okay, so go to the constraint. So this is fixed condition. If it is a simply supported, then one of the degree of freedom we have to make it free. So there are 6 degrees of freedom, 3 translational, 1, 2, 3, 3 translational, 3 rotational. Okay, so we have to select the node. All nodes are need to be selected and then create. So here it is a triangle. You can see I can increase the size of the triangle also here. If I go to the update, 10. Okay, so not required to go to the update, only you can put it here value, automatically size will be increases. Go to the return. Again, one more load collector we require to define, that is force. So go to the load collector. Then here it is put force. Color need to be changed. I will put it red color. No card image. Create. Here it is force is created. Immediately we have to define the force on this direction. So go to the analysis page. Force. Create the force on the node. This node we need to select. Okay. Then magnitude we have to put 1 lakh Newton. 1, 2, 3, 5. 1 lakh Newton. Magnitude means that how many size of that arrow. Okay, here type of load is force. Then direction we have to define in positive x direction. Look at here, this is the x direction na? So x direction you can observe here. Okay, look at here. So here I have to pull like this. So x direction we have to choose. If it is a like this vertical, then we have to choose the y direction. Now I am going to use the x direction, positive direction. If it is a compressive, then here it is a minus 1 lakh. Okay, compressive force. Here it is a tensile force, so we have to give the 1 lakh x direction. So I will select here and then create. So here it is, arrow is selected. Okay, so I can look at here. I can use the different panels of visualization. Analysis is linear static. Any name you can put. Static analysis, linear static. Here we have to choose the linear static. If it is heat transfer, normal modes, buckling, frequency analysis, non-linear analysis, we can choose different analysis. Here it is required to choose the linear static. Then SPC, we have to define SPC to SPC. Just we have to define, link it, load to force. So automatically it will be picked up. If it is a temperature and other things, we have to on it. Likewise, if it is not, then you can off it. So these are the required to assign to this force and this one, and then create it. So here it is a load step is created. So this is how we have created MHPCLL formula. Here history is generated, no color is repeated. Now we can go for the OptiStruct. We have used OptiStruct here, you know, that OptiStruct solver we have used. Okay, so that's why we have to use the OptiStruct here. Okay, load, go to the analysis page, go to the OptiStruct. Okay, so that whatever the model we have prepared, that would be saved in .fem file. .fem file. Okay, here export option all, run analysis, memory default. If it is optimization related problem, we have to take optimization. Otherwise, we have to keep as a analyze. Okay, then memory default. Okay, then go to the OptiStruct. It will ask you going to overwrite. I don't have problem if it is overwrite. If you do have a problem to overwrite, then we can change here, instead of 11, you can put 12 here. Okay, so that will be saved again. So I will overwrite here S. So it is going to solve. Okay, as like iteration 1, iteration 2, iteration 3, and then you will get the job completed, end of solver. You can, if it is an error in your model, then it will be displayed here. Then you can see here whatever the calculations are there, that will be done, and the amount of memory allocated for the run is 100 MB. This run will use in-core processing in the solver. Now that problem is solved and it is stored in the memory. Okay, now either you can view from here, okay, or maybe you can view from Hyperview. Hyperview, one of the branch in the HyperWorks, like Hypermesh, and that you can view from here. So if I go to the Hyperview, one more window will be open. Okay, and that make sure that the same file is loaded here, hm11.h3d. That was a FEM, but here the answers will be saved in the .h3d file. So these are the extension, do remember. Okay, now we have to find out the stress value and displacement value, right? So you have to go to the contour. Okay, then contour, you will find first, you can find first displacement here, displacement, and here stress value. So I will go to the displacement and apply. So you can see here the displacement value is here, that 1.213 e raised to minus 1. E raised to minus 1 means 0.1213. Okay, 0.121. So we can compare with our analytical method. So you can see here 0.12 mm. So it is closely equal to the this analytical one, 0.12. So it is here, and here it is in minus 1. 10 raised to minus 1 means it is 0.12. And then elemental stress, apply. Here it is showing 0 value. Why? Because we required linear means axial stress, not all stresses. So here it is C rod axial, we need to define axial stress, apply. So you can see here 5.93 e raised to plus 1. Plus 1 means 10 raised to 1 means 50.93. So you can check out your answer, 50.95. This is the exact solution, and this is the approximate solution, whatever we are using by solve by using software, 50.95 and 50.93. So very minor difference. So that is what I am telling. By numerical method, we are reaching to the actual one, close to the actual one. So it doesn't matter 50.93 and 50.95. For the big problems, that will be increased, but it doesn't matter. Okay, at least we can able to reach to the exact one, able to reach up to the exact one. Okay, so these are the two, this one contours. So I will go to the again displacement and I can apply here 3D also, a 3D appearance. So preference option, then visualization. Here C rod element. You can put a cylinder here for rod because it is a solid circular section, means it is cylinder, and say apply. Okay, so you can see here what are the different displacement at different location you can find out, and that are for red color it is up to here, and for this one, this color, this much displacement is there. So that is what here, and even though you can run the model also, it is not showing properly because it is a tensile, but whenever there is a bending it is clearly visible. Okay, so this is how it is required to do it. So I have recorded my session. I can upload it on this particular Teams, so you can, as and when it is required, you can use it. Okay. Yes, is that clear, everyone? Now I will just quickly take attendance and some question answering. Uh, so while giving attendance, let me know the wood is what type of material as well as composite is what type of material. You have to put it into chat box. Hello, am I audible, na? Shreyas.